Hi everyone, this is just a short video of what eccentricity means, and the next video is going to be 4 specific examples, 2 hyperbolas, 1 parabola, and 1 ellipse. So this video is just more definitional, and I'm going to show you a picture of the graphs. So basically, the eccentricity, E of a quadratic equation, which means the ellipse or hyperbola, is defined as E equals C over A. And hopefully you've already know how to draw ellipses and hyperbolas. You know C is your focal part and A is from your major, the length of the major axis, whether it be the ellipse or the hyperbola. So the eccentricity of a quadratic equation represents the flatness of its graph. So if C gets closer to A, and you probably already noticed this, then E, this eccentricity, is near 1, and the graph is quite flat. And if you notice here on this part, the eccentricity of a parabola is 1. So by definition, the graph is quite flat. That means C equals A. The eccentricity of an ellipse is between 0 and 1. Because remember, and the circle there is none because it's 0. The circle is round, so it's not flattening out anywhere. However, when we get to an ellipse, we're flattening out both pieces. We're like squashing on the circle. So this is actually quite flat here. And remember, your circle formula is, you could say, is simply x squared plus y squared, if this is the center, equals r squared. And then with the ellipse, we're actually dividing it by a fraction. So we could say this is a squared, because this is the flatter part, plus y squared over b squared equals 1. So it's kind of like on a line where you're flattening up the slope. So that's where the flatness comes in. Okay, and the Latus Rectum, I call it the LR, is the chord passing through the focus and is perpendicular to the axis. And then you have your formulas here. So let me show you the 3 examples I have here. They're not actually worked out problems. So basically, here's your parabola. Your directress is here. The center is in the midpoint between the focus here and the directress and the focus here. So it's 3 here. That's your A. Okay? So basically this is your A, and your C equals your A. Because C is the length from the vertex to the focus. So we'll call that focus. So that means eccentricity, or I'm just going to say E, is 1. And the Latus Rectum is 4A, and we already went over that in another video. Okay, and the next one is ellipse. Of course, you know that the larger length, the major axis is A, the minor axis is your B part, and the minor axis here is shorter, so it goes under the Y. And C is this length right here. All right? It's a length from the center to the focus. And then A, I'll put A in purple, I guess. A is the length between the center and the end point. So you notice that C is smaller than A. Okay? And therefore, your eccentricity is going to be between 0 and 1, which is basically these fractions in here. Okay? The hyperbola spreads out. So it's, remember, a hyperbola is just an ellipse split open. All right? In this case, our C is bigger than A, because our A is the the center to the vertex here, but our C is the center to the focus there. So since C is greater than A, that means the eccentricity is bigger than 1. And it has the same formula for the latus rectum. Okay, the next video is I'm going to give 4 examples, specific examples that you might have on a test or something, where you have to determine the eccentricity and the latus rectum. And they're going to be the parabola, 2 hyperbolas, and the ellipse. Thank you and have a nice day.